Hello, and a really big warm welcome to this section where we're going to be taking a look at computer programming and Python fundamentals. This is section 1 of the exam, and it makes up 18% of your possible maximum score, with 7 items of the exam coming from this section. So we better make sure that we are good and skilled on this area. The exam objectives that we're going to be taking a look at include understanding fundamental terms and definition. And we can see the exam number 30-02, and then we're looking at objective 1.1. When we look at objective 1.2, we need to understand Python's logic and structure. In 1.3, we need to introduce the idea of literals and variables into our code and use different numbering systems. For 1.4, we need to choose operators and data types that are appropriate or adequate for the problem that we're trying to resolve. And finally, we're looking at 1.5, performing input and output operations from the console. Now, one of the first things that we need to get to grips with is that Python is an interpreted language. Now, when we talk about interpreting, the source code, or our Python script, is executed line by line by the interpreter. The code, or our script, can be run as is without any pre-compilation. When we talk about the interpreter is the program on your computer system that directly reads and executes the code. In the case of Python, this is going to be python.exe when we're talking about Windows, or in Mac OS and Linux, it's often going to be Python 3 as the executable. It's Python that takes care of converting the high-level language that we write into the machine code ready for execution. The compilation from our high-level language into machine code happens at runtime. So Python is an interpreted language, as is Ruby. We can create Ruby scripts much in the same way as Python script, and the Ruby interpreter will compile and execute the code. When we talk about compiled languages, this could be a language like C. Many programs in Linux are written in C, where we first create our text-based source code, and then we use the C compiler to compile the code into machine code ready for execution. Similar to C, C# is compiled before runtime, but there's a little twist here. It's compiled into an intermediate language. The intermediate language is going to be read by the .NET framework on each of the target machines, allowing then for cross-platform operation. With C code, I have to compile for Windows, and I have to compile for Linux, and I'd have to compile for Mac OS. With C#, we compile to the intermediate language, and the intermediate language then converts to the appropriate machine code on the .NET framework of the receiving machine. We're going to move into our demonstration now, and this is, of course, where you're going to get good hands-on experience. We're going to be taking a look at creating a very simple Hello World Python script. We can execute this, and we can also look at the timing, how long it takes to run the program. We can create a Hello World program and compile this in the C language, and then again take a look at the execution time and how the program is run. Come on, let's find our environment. For this, we will be working on Linux, so feel free just to sit and watch if you don't have a Linux system to work on. Now, we're working at the command line of my Linux system. We really do not need this for the exam, but you need a good understanding that Python is an interpreted language, and we have other languages that are compiled languages. And one of the best ways to understand that is to really see some of the differences. So we're going to begin by taking a look at our Python language and the interpreted language. So if I just go into a simple editor, nano, and we just call it, let's say, hello.py, and we can go through and create our code. We know now that this should be pretty simple, so we can go through and type print, open up our parentheses, and then inside of our quotes, we can go through and put hello world, and then close our quotes and close the parentheses. So this is all that we need to be able to print the message to the screen. We're always going to keep it as this text file, and this, if you like, is our source code. So we can use Control and X to save, and then we can go through and save it. But we can't execute the file directly. We have to specify the interpreter to use. So we can go through and open it with Python 3 and feed into it then our hello py, and we get hello world. It's compiled at runtime by the interpreter Python 3 in this case. If we look at timing this, it's not going to take too long, but if I go through and look at Python 3 and then hello.py, as we run it, we can see then the real time is the total time that it took, and it took 0.015 seconds. But that included the compilation. So we took the source code, compiled it inside our interpreter, and executed the code. We still only have, when I look in the directory, the hello.py file, so the file never changes. Whereas if we look at something like our C language, the C language is an interpreted language. Let's go through and just make sure that we've got everything we need to work with this. So I'm going to do a sudo apt update. This is just updating my software repositories, so I know then what's available online. And I'm going to do a sudo apt install. So I'm going to install from the internet the build essential group. This should give me more than enough to be able to compile C code. And they seem already installed and up and running. So now it's just a matter of creating my C code. This is going to be a little bit more complex, but not necessarily that much. The code is going to be small. So I'm going to call it hello.c. .c is often the extension we give to our C source files so we can identify them. We're going to go through, and this is not a comment, it's an instruction for the compiler, and we want it to include a header file for standard io.h so we can do our input-output operations. We're going to specify that we have a main program, and this main program returns an integer. I don't need to accept any arguments for main. And then we have our block of code. Inside of our block of code, we're going to have then our print F statement, and we can go through and have hello world printing out, followed by a new line, close the parentheses, but we also need an end of line marker. We should be returning something, and we're going to return success, so return 0, again the end of line, and we can then close our block of code with the brace brackets. So the language itself is a little bit more verbose, but we can't execute this code. We can only compile it. But if I then go through and save it, I can then use the C compiler. We can send the output to a program that we're going to call hello, and we're going to read in our hello.c file. So this is now compiling our code. We take the high-level language and then produce machine code. When I look at the files that I have now, I've got the original Python file, which is nothing to do with what we're seeing now, but I've got my source code and we've got my hello program. It's the hello program that we execute. And I get hello world coming back. Now again, both of these programs are really simple, so I don't expect there to be a lot of difference in the execution time, but out of interest, let's go through now and look at this. So it took 0.02, so the execution was quicker. It was 0.015 before, and we can go back and double check it so we can see on the screen together that where we have to compile and execute, there is a slight overhead. So if we go through and look at our Python 3, executing our hello.py file, we can see in this case it's taking 0.013 seconds, but that's still quite a bit slower than the C program. So compiled languages should run more quickly because they don't need the interpreter to compile at runtime.